Welcome back to Hardware Unboxed. Today we're checking out Intel's fastest Alder Lake mobile processor, the Core i9-12900HK, and pitting it up against a range of other mobile products. In particular, I want to investigate Intel's bold claims of being the fastest mobile CPU, outperforming this beast, the Apple M1 Pro in the MacBook Pro. But I'll also be comparing it to the Core i7-12700H we already looked at, and the new Ryzen 9 6900HS from AMD, plus of course many other chips. Compared to the i7-12700H, the Core i9-12900HK is a simple clock speed increase, same core configuration with 6 P cores and 8 E cores for a total of 20 threads, but clocks are now between 100 and 300 MHz higher. For example, the 12900HK can hit 5 GHz peak on the P cores, compared to 4.7 GHz with the Core i7. In the past, we've seen the Core i9s being slightly better binned than the Core i7s, so sustained performance is a little better under the same 45 watt power limit, but we'll have to assess that in today's testing. The test system for today is a bit of a beast. It's the MSI GE76 Raider, which on its way to us had a nice long holiday at our local airport, courtesy of a hopeless courier company. Plenty of time to rest up and prepare for the benchmark onslaught. We've tested the GE76 a couple of times in the past, and it's quite clearly designed for high-end laptop gaming, as it includes not only the 12900HK, but also Nvidia's flagship laptop GPU, the GeForce RTX 3080 Ti laptop with a power range of 150 to 175 watts. Whether or not this system is right for you depends on your needs, but I wouldn't say it's designed for portability. Being a 17-inch chassis that weighs nearly 3 kilograms without factoring in the huge power brick, the GE76 is a desktop replacement intended to be hooked up to wall power at all times, and only moved occasionally. It does have a 99.9 watt-hour battery, but battery life is pretty bad, and really I wouldn't want to use it on battery. I prefer slimmer and lighter systems personally when buying a laptop, but certainly these sorts of machines are also popular, or they wouldn't make them. As for other hardware, the GE76 is equipped with 32GB of DDR5 4800 memory in a dual stick configuration, which is what we've seen used for all 2022 gaming laptops so far. In this configuration, there's a 17.3-inch 1080p 360Hz display, though it's also available in 1440p and 4K options. Our testing today has been conducted in 2 power configurations, a long-term PL1 power limit of 45 watts, Intel's default spec for these chips, as well as 75 watts, which is a common boosted power level seen across many laptop vendors. These will be compared apples to apples with other laptop chips running at the same configuration, which gives us the best look at how these CPUs compare in a fair benchmark battle. If we compared one chip at 75 watts to another at 60 watts, we'd really only be comparing which specific laptop design can send the most power to the CPU, not which CPU actually performs better, which is why we test like this. Boost PL2 power is set to Intel's default of 115 watts in both instances. Testing like this also gives you guys the most useful information that can be applied to a wide range of laptops. If you're buying a thinner and lighter system, the 45 watt numbers will be most important, while those after a beefier system with more cooling power should look at 75 watts. On to the results. In Cinebench R23 multi-threading, when the Core i9-12900HK is limited to its default of 45 watts, it is the fastest CPU in the chart, with a score of 13,400 points. This does allow it to outperform the Apple M1 Pro, although Apple's chip is consuming roughly 35 watts of package power, not 45 watts, which is a trend you'll see across most of the charts. Still, the 12900HK is the winner here by 8%, and in turn it's also faster than AMD's new 35 watt CPU by 15%. What perhaps surprised me the most was the margin between the 12900HK and 12700H. There really isn't that much separating these parts, just a 3% increase in favour of the Core i9. Both parts do have the same core count and are operating under the same power limit, so the only difference here is binning and optimization, which doesn't appear to be enhancing performance significantly. With that said, the performance gain compared to the 11980HK from last generation is large, a very solid 23% increase. At 75 watts, we're seeing a continuation of what was shown at 45 watts. However, the gap between the 12900HK and 12700H has now shrunk to nothing, at least with the models we tested. This does give the Core i9 a 16% lead over the Ryzen 9 6900HS, as Alder Lake is able to deliver higher performance per watt in the high power range compared to something like Rembrandt, but it doesn't exactly scream to buyers that the Core i9 is a good value choice over the Core i7. A larger performance delta between the 12900HK and 12700H was observed in the single-threaded test. With the 12900HK hitting 5 GHz, it's 5% faster than the 12700H from a 6% boosted clock speed, so that's pretty much as expected. Alder Lake is quite a bit faster than the M1 Pro here, a huge 25% performance lead in single-threaded workloads like this, and 19% faster than AMD's Ryzen 9 6900HS. There's no doubting that Alder Lake's P-cores have the performance crown for single-thread this generation. There's a mixture of good and bad when looking at the handbrake results for 45-watt class CPUs and lower. The 12900HK is faster than the 12700H in this test, but only by 2%, which is rather negligible. It's only able to match the Ryzen 9 6900HS as well, despite the 6900HS being a 35-watt CPU. However, the 12900HK is clearly faster than the M1 Pro, despite our M1 testing using the native Apple Silicon version of Handbrake for CPU encoding. The M1 just isn't very good at heavy CPU encoding like this compared to Intel or AMD, which gives the 12900HK a 25% performance advantage. At 75 watts, the results are pretty similar to with Cinebench in that the 12900HK and 12700H delivered basically the same result, and both are a similar margin faster than the 6900HS running at the same power limit, 4% faster. High power configurations smoke the M1 Pro at the cost of power consumption, which is obviously much higher than Apple's SoC. Blender was a particularly strong result for Apple Silicon, and here the 12900HK is able to match that part, although at a higher power configuration, 45 watts versus roughly 35 watts. Again, we just aren't seeing a huge difference between the 12900HK and 12700H for this heavy multi-threaded test, and nothing I've seen so far suggests it makes sense to buy the Core i9 for these applications. Even at 75 watts, which more Core i9 laptops are going to be capable of doing, the gap is negligible for the top Intel Alder Lake parts. For code compilation, my advice is to buy an Alder Lake processor because they are clearly faster than the competition and older options. The 12900HK is 32% faster than the 11980HK in this Chromium compile and 24% faster than the 6900HS. These are pretty big margins for laptops. But once again, a very common theme of this review so far, the 12900HK and 12700H are neck and neck, which makes upgrading to the Core i9 from the Core i7 a bit pointless. And then once again at 75 watts, I was seeing basically the same results with the two Alder Lake parts I've tested so far, suggesting there is no performance per watt advantage for the Core i9 at these higher power levels. In my MATLAB testing, the 12900HK and 12700H delivered the same performance, which was a bit of a surprising result given the short time frame of this workload, but here we are, same result. Aside from the lack of an upgrade going from Core i7 to Core i9, it's still a good result given it's 17% faster than the 11980HK and 23% faster than the 6900HS. The M1 Pro is in a rather forgettable position for this application given it has to run in an emulated mode which destroys performance. In Microsoft Excel, we see the same thing as previous where the 12900HK and 12700H are neck and neck. Like MATLAB, this benchmark is run in the boost state, and as we've seen previously, high power levels, there's really nothing separating these two CPUs. So when both are smashing 100 watts plus, there's no difference. However, Alder Lake is still mighty impressive here, basically destroying every other part in the chart thanks to improvements to cache and the upgrade to DDR5 memory. PCMark's applications workload that tests the Microsoft Office suite is one of the strongest results for the 12900HK versus 12700H, and we're finally seeing some separation there. The Core i9 processor is 9% faster, which at least gives buyers some reason to get the Core i9, as that sort of margin is outside our usual margin of calling it a tie. The 12900HK is also able to hold handy leads over the 6900HS, 15%, and the previous 11980HK, 21%. In 7-zip compression, I didn't spot a difference between the 12900HK and 12700H. In fact, here my 12700H laptops on average was slightly faster, but really this is a tie and within the margin of error. Intel is able to hold a performance lead over the M1 Pro. Apple Silicon is fast, but the 12900HK is 7% faster, albeit at a much higher power level given this is run mostly in the boost state. But for decompression, the fat P-cores are able to gobble up this task nicely, beating the M1 Pro by a huge 52% margin. There isn't much separating the 12900HK and AMD's new Ryzen 9 6900HS processor, so really all the current gen high-end chips are about equal here. In Acrobat PDF exporting, we see the benefit of the higher single-core turbo clock the 12900HK is capable of versus the 12700H, which increases performance by 4%. It's not enough to take top spot off Apple though. The 12900HK comes in 8% slower than the M1 Pro in what is one of the strongest results for Apple that I've seen. Adobe Photoshop is another lightly threaded workload, and it's here where the 12900HK is quite impressive, putting up the fastest score yet in the Puget Systems benchmark. 4% faster than the 12700H and 17% faster than the 6900HS. There's a big reason to upgrade from 11th gen silicon or older as well, as the 12900HK is a sizable 36% faster than the 11980HK. In FL Studio, the 12900HK is the fastest CPU I've tested as well, though it is only 5% faster than the 12700H, and the margins between all of these parts is quite small for exporting a track at high quality levels. Moving over now to some mixed workloads in Adobe Premiere Pro, there is definitely a reason to go for a 12900HK configuration over lower tier parts, especially with a high performance GPU. The GE76 was about 10% faster than the 12700H model with the same RTX 3080 Ti GPU, and this allowed for a 23% lead on the M1 Pro. The M1 result is extremely impressive given its overall power level and lack of high performance discrete graphics, but for the absolute best performance this generation, you should be going with something Intel, especially as the 12900HK plus 3080 Ti configuration is something like 60% faster at exporting. In After Effects, the 12900HK is also the fastest configuration tested and 7% ahead of the 12700H model using a similar GPU. That's one of the better results we've seen so far comparing the Core i9 and Core i7 models. Lastly, we'll look at Agisoft Metashape photogrammetry performance, and there's nothing separating the Core i9 and Core i7 systems here, which is more in line with some of our CPU-heavy workloads we've looked at earlier in this review. Very fast performance here as you'd expect and want from a high-end system with a powerful CPU and GPU. When looking at CPU power scaling, there's only one really interesting observation, and that's how the 12900HK fares compared to the 12700H in performance per watt. At least with the samples we've tested so far, the 12900HK is only a very minor improvement in efficiency, and that efficiency gap tapers off at around 75 to 85 watts. Given the actual silicon is basically the same with these parts, the main reason for the 12900HK's improved efficiency is a better bin on those parts, but for this generation it still looks like the 12700H is receiving very good silicon. In contrast with the 11980HK versus 11800H, there was a more substantial gap in efficiency across the power range. Not a huge gap or anything, but indicative of a greater degree of binning. Without a larger difference between 12700H and 12900HK performance per watt, the best Alder Lake part isn't quite as efficient as the M1 Pro. I should note here that previously we had the M1 Pro at 40 watts, whereas its actual package power, the same measurement used for Intel and AMD CPUs, is more like 35 watts, so we've corrected that here. The M1 Pro is just 6% faster at 35 watts, and it's using a more advanced 5nm process node, so it's not exactly a stunning victory for Apple in multi-thread efficiency, but it is better. The 12900HK is also very slightly more efficient than AMD's new Ryzen 9 6900HS at the same 35 watt package power, though the difference is negligible, and Intel has a big advantage at higher power levels. Where the difference isn't so negligible is in single thread power as measured at the wall. The M1 Pro clocking up to just 3.2 GHz is ridiculously efficient in comparison to most other processors in this chart, and that's where its insane performance per watt and extended battery life comes from. Apple has a big advantage when tasks are lightly threaded. In contrast, Intel are going for the win with single thread performance, and that causes quite a high level of power consumption, 33 watts when pushing 5 GHz, which is a fair bit higher than the 12700H despite just a 6% increase in frequency. I was originally going to run a big section on gaming performance for the 12900HK, but the reality is the results are extremely boring. In comparison to the Core i7 12700H, the 12900HK performs basically the same across our benchmark suite. A couple of margins here and there using the same RTX 3080 Ti laptop GPU, but on the whole I'd say this sort of performance is equal for 1080p gaming, including titles played at low or competitive settings like CSGO and Rainbow Six Siege. I do have a more detailed breakdown available in my 12700H review, but basically nothing about the 12900HK changes what was seen there. Alder Lake is currently the fastest series of laptop processors for gaming, although the exact margins in comparison to 11th gen and Ryzen APUs vary, usually up to a 25% gain when CPU limited in the best case, and much much lower when GPU limited. You'll also need a high-end GPU to take advantage of these differences and be playing at 1080p. Overall, there's kind of two ways to look at the Core i9-12900HK. On the one hand, it's just as impressive as the Core i7-12700H we looked at a few weeks back and packs all the same performance and platform advantages. It's a fast processor, the fastest on the market for all of multi-thread, single-thread and gaming, and it has a really robust collection of technologies, including DDR5 support and PCIe 4.0. On the other hand, like with the 11th gen Core i9 series, the 12700HK feels a bit pointless for most buyers. The performance uplift over the 12700H is only a few percent in most cases, and can actually be the same at higher power levels, pointing to only a limited efficiency improvement. The biggest gains were largely seen in single or lightly threaded productivity apps, where the boost up to a 5 GHz single core turbo clock is able to deliver a 10% performance gain at best. Of course, if you want the best of the best, the Core i9 is that part, but like with a lot of flagship parts, you'll end up paying a hefty premium for a very small real-world upgrade in performance. So purely looking at Intel's lineup right now, I'd definitely be looking at laptops that use Core i7 processors instead of the Core i9-12900HK. Provided the rest of the configuration is the same, you could end up saving a few $100s. But of course, not every laptop will have a Core i7 option. At times, the 12900HK might be your only option, and in those situations, there isn't anything wrong with the 12900HK at all, as it is very much a fast laptop processor. During Intel's announcement presentation, they made a big deal about the 12900HK being the fastest mobile processor ever, showing this slide comparing their new part to the M1 Max and older generation parts. Given the M1 Max CPU is the same as the M1 Pro we tested, I can say this slide is partially true and partially misleading. In this area where Intel compares the 12900HK to M1 Max at 35 watts, they show the 12900HK ahead. This can be true depending on the benchmark, but there are more instances where the M1 is either on par or faster at the same power level in my testing. We're usually talking small margins though. The 12900HK is definitely competitive with Apple in performance per watt, but I wouldn't go as far to say it's clearly better. Where the 12900HK clearly has an edge though is in overall performance. At 45 watts and above, the 12900HK almost always beats the M1 Pro, and when we start pushing up to the, say, 75 watt range, the new Alder Lake Core i9 is a decent amount faster in a lot of heavy CPU workloads. So if you want the absolute fastest workstation laptop for stuff like code compilation, 3D rendering, video editing, and so on, the 12900HK will be providing that, especially when equipped with a top-end GPU. But the way in which Intel wins is through increasing power consumption, which is only suitable for a certain type of laptop. The GE76 is one of those systems. It's big, it's heavy, it's designed to sit on a desk and be plugged in most of the time. Intel won't have the same lead on Apple or AMD in thinner battery-oriented systems. Performance definitely will still be competitive, but you won't see 15 or 20% better performance for CPU-heavy tasks. This brings up the topic of battery life. I have seen some criticism of Alder Lake's battery life based on testing the GE76, but I really don't see much value in that. The GE76 isn't designed with battery life in mind. It's clearly much larger and heavier than something like the Zephyrus G14 using Ryzen 6000 or even the MacBook Pro over here, and is therefore less portable and less likely to be used on battery. I certainly wouldn't want to be using a 3 kilogram laptop on the go. So if I sit here and say the GE76 has worse battery life, and let's be clear, it definitely does, I'm really just comparing apples to oranges, and battery life isn't based on the CPU alone. It's also based on the entire platform, including the GPU, display, and other components. So making broad statements about Alder Lake battery life based on just one system would be pretty misleading. To fairly compare a CPU like the Core i9-12900HK in battery life to other laptops, we need basically the same laptop to test, one with this CPU in it, and one with the alternate like an AMD Ryzen part, or alternatively they could be very similar sorts of systems. Hopefully that will be possible in the future, but it isn't right now. All I can tell you is that the MacBook Pro has excellent battery life, the Zephyrus G14 is pretty good, and the GE76 isn't great. How Alder Lake fares in battery life efficiency overall will remain a mystery until we're able to test more portability-focused systems. Anyway, that's it for our testing of the Intel Core i9-12900HK in this MSI GE76 laptop. If you're interested in supporting our channel and the independent testing that we do, please consider going over to our Patreon and Floatplane accounts. Links are in the description below. You'll gain access to things like our Discord community, monthly live streams, behind the scenes videos, and of course, you'll just be supporting the channel. So thanks very much for watching, and I'll catch you in the next one.